First up is configuration management. Why do we need configuration management? Because even fairly small modern networks can get very complex very fast. Configuration management, or CM, is a discipline that is used to evaluate, coordinate, approve, deny, or implement change in or to an IT system. Configuration management plays a vital role in any network beyond the most simplistic of small office, home office networks. It helps to ensure that the network runs efficiently and smoothly. Network administrators and support staff will play a vital role in developing and implementing any CM system or process. Now that you know what configuration management is, let's talk about documentation. Documentation plays a key role in any configuration management system that gets developed. In the CM process, documentation is used to help evaluate and plan proposed changes. Documentation is also used to help in asset management, network maintenance, and vendor evaluations. The documentation that is created will depend upon the complexity of the systems under consideration. However, even if your organization doesn't implement a true CM style, some documentation should still be kept to reduce the burden on network personnel and to ease administrative management of the network. Some of the documentation that should be kept include policies and procedures. Policies are a set of guidelines that establish how the network is to be configured and operated. They also set the expected behavior of the people within the organization. As a general rule, policies are put into effect at the mid to upper management level. Procedures, on the other hand, are a set of documents that detail how the policies are to be implemented. As a general rule, procedures are set by the management of the level that's affected by the policy, and they get down to the step-by-step process of how to do things. Asset management documentation should also be maintained. This covers a broad category of documentation that's often used to help in the change management process. Asset management documentation contains detailed information on what assets are present. It also includes the maintenance history for those assets. This documentation is often used to help track update and upgrade cycles. Physical network diagrams should also be kept. These are a map or diagram of all network devices and how they connect. A physical network diagram specifies the cabling, connectors, and physical cabling runs. It will also include cable management documentation, which is considered a subcategory of the physical network diagram. The cabling management documentation will contain a wiring scheme, which establishes the type of cabling and the connectors used. It also defines the allowed standards for wiring those cables. Your documentation should also include a logical network diagram. It's similar to a physical network diagram, but more detailed. It provides details on the IP address scheme, active ports, protocols that are allowed on the network, etc., etc. Your logical network diagram also details connected networks. So what local area networks are present, or which virtual local area networks are present, so on and so forth. Part of your logical network diagram also details IP address utilization. IP address utilization can greatly affect the efficiency and performance of the network by allowing you to know which LANs or VLANs have space on which nodes can be added. Your physical and logical network diagrams may be combined into a single document. Vendor documentation also plays a role in supporting configuration management. It covers a broad category of documentation that can include the approved vendor list, the vendor approval process, and purchase order documentation. There are some common vendor documents that you should know. First up is the Memorandum of Understanding, or MOU. This is an agreement between two or more organizations that detail how those organizations are to take some common course of action. It is also often referred to as a letter of intent. It is not legally binding, but it does often lead towards a binding agreement. Then there is the Statement of Work, or the SOW, the SOW. It's a detailed document that specifies what work is to be performed, the expected outcome or deliverables, and the timelines to perform the work. The Statement of Work is often a key document in project management. Included in some vendor documentation is a Master License Agreement, or MLA. This is a legal agreement between two entities in which one agrees to pay the other for the use of a specific piece of software or software package for a specific period of time. Often, instead of being called a Master License Agreement, it is referred to as just a License Agreement. Last up is the Service Level Agreement, or SLA. It details the allowable amount of response time the vendor has to resolve an issue or problem. Most commonly, it is associated with a service contract. I will begin by talking about backups. Backups are an essential part of any configuration management system. That's because small changes in a network device's configuration can introduce unexpected consequences into that network. In addition, there is always the possibility of a failure of a key component, which can lead to the loss of data or functionality. Backups play a key role in recovering from unexpected consequences or from the failure of a key component. Backup schedules must be implemented, and periodic tests should be conducted to ensure that the backup process is working. There's nothing worse than installing a backup and finding out that you really backed up nothing. There are three basic types of backups. There is the full backup. All data on the targeted system is backed up. This is the slowest backup method with the highest storage requirements, but it does lead to the fastest recovery method. When recovering using a full backup, it only requires the last full backup file. Then there's the incremental backup. With this type, only new or modified files are backed up. This is the fastest backup method with the lowest storage requirements, but it also leads to the slowest recovery method. The recovery process with incremental backups requires the last full backup file and all of the incremental backup files. The middle ground is the differential backup. Only data that is changed since the last full backup is saved. The time to back up is moderate, and it requires a moderate amount of storage, but it also is the middle ground on the length of time for recovery. The recovery process requires the last full backup file and the last differential backup file. Something else that needs to be backed up are your configuration files of network devices. Once a network device has been configured and it's operating as expected, a backup of the configuration files and operating system should be done. This helps to speed up the recovery time in cases of equipment failure or when a change to the configuration has introduced unexpected consequences. Having the configuration file backups on hand means that you don't need to manually input it to recover in these situations. Now let's move on to bring your own device. BYOD policies, or bring your own device policies, allow employees to use their own personal devices on an organization's network. While the employees are happy that they get to use their favorite IT devices on the corporate network, IT departments aren't quite as happy about it. Why? IT departments are tasked with keeping a network safe, yet they have very little control over the devices that employees bring in. In some cases, bring your own device policies have led to the introduction of malware into an organization's network environment. This makes them very unhappy. They can implement network admission control measures, or NAC measures, in an effort to reduce the risk associated with BYOD policies and to introduce configuration management to those devices. Network admission control is a Cisco process. Microsoft uses a similar process, but it's called Network Access Protection, or NAP. While their names may be different, they still function in the same way. NAC includes more than just authenticating users and devices on the network. All of the devices that are requesting access to network resources are screened for the type of device that it is, the operating system that's used, including any updates that are present. NAC will also check for security software, making sure that it's up to date. NAC can also check for the presence of malware or other security vulnerabilities. In an advanced setup, if the device requesting the connection has been rejected, the device is then redirected to a remediation server which attempts to resolve the known issues. So if the security software is out of date, the remediation server may try and bring it up to date and then allow that device to connect to the corporate network. That